Hello everyone, welcome to 822 Day 2. Today we're going to be focusing in on our ability to write polynomials from roots, whether they are complex or real roots, and we want to make sure that we get to the standard form of the equation. So this is a little bit different than what we've done before, because usually we take the roots and we write the factored form, which is going to be a step in what we do, but then we have to go from that factored form to the standard form as well. All right, and just a bit of review, we talked about this yesterday, but the standard form looks like this, where we have all of our terms being added and subtracted together, versus the factored form, which looks like this, where we have all the parentheses being multiplied by each other. All right, so those are two different forms. So let's kind of talk about an example here real quick. So here in this problem, they're telling us the polynomial has the roots -4 and +7, all right? So, step number one here should be to write this thing in factored form, right? So write in factored form, right? Because we know how to do that. We can get an equation for sure in factored form, so we can say something like y equals, and then write our equation like this, right? Since we have two roots, we're going to have two factors. Since this root is a -4, we're going to need a factor of x plus 4. So remember that relationship between the root and what we see in that linear factor kind of flips, right? So if we have a -4, we'll get a +4. This is a +7, so we'll have a factor of x minus 7. Okay, so there it is, right? In factored form, we've got that part. The second thing we're going to do is we are going to multiply these two factors out, right? So to get to standard form, we need to multiply out. Okay, so we're going to multiply. And I'm going to do that using my box, right? The box is a great tool to help us multiply expressions like this. Okay, let me set this up. I'm going to do a 2x2 box. Reason being is because each factor has two things in it, right? So I have an x and a 4 here, so I can put that across the top. And then we have an x and a -7, so we have x minus 7 going down the side. All right, so when we multiply, we're going to multiply, right, using that lattice style multiplication. So we're going to do x times x. We've got x squared. All right, then we do x times 4. Well, that's just 4x. And then x times -7 is -7x. And then -7 times 4 is -28. Okay. So there we go. So the next thing we're going to do here after we're done multiplying is we're going to add our four boxes together. All right, so we're going to add the terms. So I'm going to say y equals x squared plus 4x minus 7x minus 28. All right, so I just took my four boxes and arranged them so that they are being added and subtracted together. All right, then we're going to combine like terms. Last step here. Okay, so we're going to say y equals, and if I'm looking at my like terms here, remember like terms are things that have the same variable raised to the same power, right? So if I'm looking at this one, this is x and it's being raised to the second power. So that would not be a like term with this one. This is x, but it's not being raised to the second power. So I cannot combine these two. But these two I could. They both have an x. They're both being raised to the first power. So the positive 4x and the -7x, those can be combined. Okay, so I'm going to go ahead and do that. I'm going to say y equals x squared. 4 -7 make -3x minus 28. And there is our polynomial in standard form. All right, so if you look at the individual steps that we took, like writing in factored form, easy, right? Multiplying, we've been doing that since 9th grade. Adding terms, right? So just arranging the terms based on what you see in the box. Not hard at all. And then combining like terms, we've been doing that since junior high. There's really no part of this that is actually hard. It's just remembering what to do. All right. And now we're going to kick it up a notch because we're going to do it with some complex roots. All right. So we've got 5i and -5i. So I'm going to start with that same first step. I'm going to write the factored form of my polynomial using the roots that they gave me here. All right, so if I have a positive 5i, I'm going to have a factor of x minus 5i. And if I have a root of -5i, then I need a factor with x plus 5i. Okay, so there's my two factors. I'm going to set up a box so that I can multiply them, right? Because again, we want to get to that standard form. The way that we do that is we take our factors and we actually multiply them. So we're going to have x and minus 5i, and then over here we'll have x and positive 5i. Right, so just arrange my factors along the sides. Again, 2 by 2 because each of my factors has two things. All right, so x times x is x squared. And then this is where things can get a little bit tricky. This is kind of new, right? So I'm doing x times negative 5i. Just multiply the three things. We're going to have negative 5i x. Okay, that's as good as that's going to get. We're going to do the same thing here. 5 times I times x. So we get 5ix. And then we multiply these two, right? 5 times 5 is, or 5 times negative 5 is negative 25. I times I is I squared. Okay, so make sure that's a common mistake right there. Make sure you pay attention to that exponent. When you multiply those two things, you're going to end up with I squared there. So now I'm going to add my four boxes together. So we've got x squared minus 5ix plus 5ix minus 25i squared. And then we're going to look to combine like terms. So just like in that previous problem, anything that has the same variable raised to the same power. Okay, so that would be these two right here. They both have an ix. They're both raised to the first power. So here we go. So we got x squared. If I do negative 5 and positive 5 and I add those together, these are going to zero out. They essentially cancel. So all that's left really is this negative 25i squared. Okay. Now this is an extra layer here. We got to take care of the powers of I. If we recall from a previous lesson, I squared is the same thing as negative 1, right? So I squared equals negative 1. This is the most common power of I that's going to pop up in these problems. But when we see it, we do need to simplify it down to negative 1. All right, so we've got x squared minus 25 times negative 1, right, instead of I squared. The I squared got replaced. Okay. Now negative 25 times negative 1, negative times a negative is a positive, so this will be x squared plus 25. There is my standard form. All right, seems like a lot, but there's really no part of that that's hard. You just got to take it a piece at a time and keep progressing through. All right. Okay. So let's go back. This is just a little bit of quiz review. Since we do have a quiz tomorrow, I want to make sure that you are ready for it. Last week's quiz, we saw a problem just like this, and there was a little bit of a struggle with the sketches. We went over it again last Friday, and I'm going to go over it again today. Hopefully we do a little bit better on this one, but we want to make a quick sketch of this polynomial, and everything you need to know to make your quick sketch is asked over here. And we do the same thing on the quiz, right? So the first thing we're going to have you do is just tell us what are the roots, right? These are the locations where we hit the x-axis. So we've got to know where those are at. To find those, we look at our linear factors, these parentheses with the x's in them, okay? So this one is an x plus 1. That tells me I'm going to have a root of negative 1. It also means on my graph that I'm going to hit the x-axis at negative 1, all right? So then I go to the next one. This one is a positive 3, right? X plus 3. So that means we're going to have a root of negative 3. So we're going to be somewhere over here. I'm going to put negative 3 there. And I know my polynomial is going to touch there. I know my polynomial is going to touch there. All right. And then I go to the next one. X minus 4 means we're going to have a root of positive 4. So that's going to be over here. So I'm going to mark the 4, plot a point. Okay, this one is at x plus 2. So we're talking about right here at negative 2. Okay, so now I can see the locations where my polynomial is going to hit that x-axis. All right, so now the thing I want to find next, I want to find the end behavior. So I want to know what the ends of my polynomial are doing. And to do that, I need to know about the leading coefficient and the degree of the polynomial. Okay, so the leading coefficient in its factored form like this is always this number out front. Okay, so that negative 2 is the leading coefficient. The degree of the polynomial is the number of linear factors that you have. All right, so if I'm looking at this, this is a linear factor, so there is 1. And then this one has an exponent of 3, so there's actually 3 of these ones. So that's 1, 2, 3, 4. There's 2 of these, so 5, 6, and then one more of these, that's 7. So there's 7 linear factors, which tells me the degree of the polynomial is 7. So we're looking at a negative odd polynomial. We have a negative leading coefficient, an odd degree polynomial, and that tells me that we're going to be going up on the left, down on the right. Okay, there is a set of notes where I gave you an entire chart with every possible end behavior on there and every possible combination of leading coefficient and degree. So you need to make sure that you have that by your side on the quiz so that you know which end behavior you need. So on my graph over here, we're going to be going up over here and down over here. Up on the left, down on the right. All right, the last thing I need to consider are double and triple roots. So remember, the -3 came from a linear factor that happened 3 times, so this is a triple. And the 4 came from a linear factor that happened twice, so this one is a double root. And you have to remember the behavior at these roots are different than a normal root like the -1 or the -2. All right, so at the -3, since it's a triple, we're going to inflect as we pass through it. And I'm going to choose a different color here. Let's go with this one. I'm going to come down here. All right, like I said, it doesn't have to be pretty, but as I pass through that -3, I'm going to flatten out. All right, that's called an inflection. And then I pass through and continue down. All right. Now the -2 is a normal root, so eventually I'm gonna turn around here and I got to come back up to pass through that -2. And then I'm going to have to turn and come back down to the -1. And the -1 is just a regular root, so we're going to pass right through that one. There we go. There's no special behavior if it's a single root. And then eventually we're going to turn, we got to come back up to the 4. But remember, the 4 is a double root. And at a double root, we bounce. Okay, so we're going to come up here, bounce off the x-axis, and come on back down to meet up with our other end of the polynomial. All right, so you can see the difference in colors there kind of highlights the difference between the ends of the polynomial and all of the squiggly stuff that happens in between. All right, guys, let's go to this last problem and we'll wrap this lesson up. So we're going to see this problem on the quiz as well, where they give us a polynomial and they want us to find the roots. This one is telling us right off the bat that the roots are going to be complex. So if you see that in the instructions, do not attempt to factor this thing. All right, instead use the quadratic formula that I give you over here. All right, so first thing we need to do is set this thing equal to 0. Since we're finding roots, roots always happen whenever the polynomial is equal to 0. Okay, so we're going to say 0 equals x squared plus 10 plus 34. That should be 10x. Typo. All right, then we want to identify our A, our B, and our C values. Okay, and just another note, if you do end up with complex roots, the only way you're going to find those complex roots is using the quadratic formula over here. Okay, so be familiar with this thing. I'm showing you how to go through that now so you're fresh on it for the quiz. All right, now the A value is the number in front of x squared, so that's going to be 1. The B value is going to be the number in front of x, so that's going to be 10. And the C value is the constant on the end, that's 34. All right, and I'm going to plug those into my quadratic formula over here. So we're going to say x equals, and we got negative b, so that'll be -10, plus or minus square root. We've got b squared, so that's going to be 10 squared, minus 4 times 1 times 34. I have to get my calculator out for that one. All over 2 times a, so 2 times 1 is just 2. And there we go. So there's the setup. Now I just got to go through and find one easy thing to do and just keep simplifying this thing until I run out of easy things to do. All right, so we're going to say x equals -10 plus or minus, and then I'm looking inside the square root. 10 squared is easy, that's 100. And then 4 times 1 times 34. I got to pull out my calculator. Let's see what we get here. 4 times 1 times 34. And you can use whatever calculator you like. So we got 136. All right. So we got minus 136 all over 2. There we go. Looking a little bit easier now. So I think we can go ahead and subtract those two numbers. So we've got x equals, we got negative 10 plus or minus, and then inside of that square root, if I do 100 minus 136, we get negative 36 over 2. And we should start to see where the complex numbers are going to come from because we're square rooting a negative right here. So that is where the issue comes in. This is going to end up being a complex number here. So if I take the square root of negative 36, right, we can rewrite that as negative 1 times 36 and then split that root up like this, right? So the square root of negative 1, we learned about that, the definition of I, right? And then the square root of 36 is 6, so we get I times 6, which is 6I. So I'd come over here and replace that entire thing with 6I. So we got x equals negative 10 plus or minus 6I all over 2. All right, and we're almost there. One last thing, if we end up with a fraction like this where we have both of these numbers in the top divisible by the number in the bottom, go ahead and divide them. All right, both numbers. So negative 10 divided by 2 is negative 5, plus or minus 6 divided by 2, which is 3I. Okay, and then in my open math, you're going to write your answers like this. We're going to say negative 5 plus 3I, comma, then negative 5 minus 3I. And there you go. All right. All right, guys. Well, good luck on your quiz tomorrow, and make sure you give the practice problems a try to prepare. Have a great day.